Okay, welcome back to the second part of Lecture 6 for Engineering 101 in 2016. So the final part of this lecture is going to be a quick and dirty introduction into the little man computer. In the actual lecture we had one of our BE graduates come in and talk a little bit about his process, but I wanted to give this as an introduction to the LMC for anyone that's kind of reviewing it or wants to re-go back over it for revision purposes, or if you happen to be doing assignment 3, though you should already have it in by now. So one of the really interesting things is that using only what we've talked about so far, so logical gates and binary kind of components, we can actually build a conceptual computer that physically computes things. And this is what we call the little man computer. So here's insert random person here. So it's called the little man computer because history is history, and it works by filling in a lot of the details from what we've been talking about in our model of a general computer. So rather than having these ideas of separate CPU, memory, input, output, blah, 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 we're actually going to fill that in. So here is an example of the little man computer. He's got 5 main components, which we'll go through in some detail in the rest of Engineering 101. But for the moment, just be aware that these exist. So he has his addressable memory, and this is a series, pretty much like a long table. You can see it on the right hand side over there, and it's just a list of addresses, very much like an address you might have for a house in a street. So the nice thing is that you don't have to tell the little man what is inside any of these boxes. You just have to tell him where they are. So let's say you give the little man number 2. What he will do is he will go over to his memory, this great big list of boxes, and he will retrieve whatever is in cell number 2. And in the examples here, you can see the number 500 is in the cell number 2. So when we talk about addressable memory, it's a key component of the little man computer, and in fact of computers in general. And it is essentially just a bunch of mailboxes associated with a bunch of addresses. And our little man, this imaginary little person that runs around inside our computer doing computations, he will go and either read things from those addresses or write things to those addresses so he can come and get them later on. He does have access to a few other things. So he has a little pocket calculator, very much like we do. His calculator can do many things. It can do addition, subtraction, multiplication, division, most any basic arithmetic process like we can. And importantly, it has a little typeface on the front where he can write down numbers, because the little man computer has no functional memory of his own whatsoever. He cannot remember things. So if he gets a number out of memory, or if he gets a number from anywhere, he always types it into his calculator for safekeeping. That way he won't forget it. So that number 123 that's in there at the moment, he has typed that in there because that's what he needs to remember for this next part. So he is also in a little box. In the original version, he's locked inside a room, and the only way he can communicate with the outside world is through the in and out baskets, which you can see on the left hand side. Now functionally, those are our input and outputs. We'll come back to them later. And the final part of the little man computer is the program counter down the bottom, and this is just a little clicker that he has. Every time he does his cycle, he'll increment it. So how does this whole cycle work? Well, so the little man has a consistent pattern that he does and then repeats it again and again and again. The interesting thing about him is that the output of this process can be very different depending on what goes on inside the memory. So here's his basic process. Step 1 is little man gets up, and the very first thing he does every single time is he goes over to the program counter and he reads the number from it. Program counter. So the program counter always starts off at 0. And that 0 isn't just a number. That number tells the little man where to go to get his first instruction. So if he reads the number 0 off the program counter, he will go straight across to memory address number 0 and get whatever is inside there. So in this example, he's going to read 0 off his program counter, wander over to memory address, that will encode the number 500, and he will, so 2, go to memory, and retrieve that number, that number. So he's going to go and get the value from 0, 0, and in this case it's going to be 500. Now that's not just a number, that number 500 is actually an encoded message to the little man, and that tells him what to do. It could be to go and get something from input, or go to get something from output, it could be to enter something into his calculator, it could be to change the program counter. There's lots of different instructions we could give him, but then all he's going to do is execute what that number tells him to do. So he's going to do whatever process it tells him to do, and then the final step is in this chain 4 is increment program counter. So the final step is to add 1 to the program counter. So let's just go through this one more time to make sure it's really, really clear. Your little man wakes up. Very first thing he does, he goes to his program counter. That, in the very first state, says 0, 0. So he goes to address, memory address 0, 0, and retrieves whatever instruction in there is there. In this case, it's the number 500. That 500 tells him to do something, whatever it happens to be, and then he goes and does that. Once that process is complete, he goes back to the program counter, he adds 1 to it, and then he goes back to sleep. And then he wakes up and repeats the process. So the second step would be, right, he goes to the program counter, now it says number 1, so he goes to memory address number 1, and he retrieves his instructions from there. In this case, his instructions are number 199, that tells him to do something, he goes away and does it, and then he comes back, increments the program counter, goes back to sleep, wakes up and repeats the process again and again and again and again. So this is the little man computer, the cyclical cycle of program counter going to memory, getting an instruction, doing it, and then incrementing the program counter. That's the basic little man computer cycle that you need to know. And I've written it out in more detail here. So there's an example of the little man computer cycle. We'll go through the details of how we give him instructions and what the instructions mean in the first part of the next lecture. You should be able to tell me what all these main components are, explain the importance of program counter, and if you're looking for a challenge, try and find out why the little man himself doesn't actually need to exist. So we'll finish it up there, and I will come and see you again on in Monday's lecture, lecture number 7.